For this problem from chapter 2, we're going to solve the equation Q equals P times the quantity 1 plus R over N to the NT for R. Now, those astute viewers will notice that this is the compound interest formula. Now, the first thing that we need to do is, well, overall we're going to try to unravel the right side. And it'll make the left side a little bit more complicated. But we're essentially going to apply inverse operations to get at this R. So since P, being the outermost operation, is multiplied, the inverse operation would be division. So we're going to divide everything by P. And that will give us Q over P equals 1 plus R over N to the NT. Now, at this point, several people will get frustrated because they don't know how to get rid of an NT power. Well, you have to think about ways to inverse that operation. The question is that an exponential operation or is it a polynomial operation? For example, if I had an x squared, just off to the side, and I wanted to inverse that, I would square root. I would use a fractional exponent, basically. But if I had something like an e to the x, I would use an ln in order to get rid of that exponent, because the exponent would come down. In this case, we have a constant in the exponent. It's not a variable, so we don't need to use logarithms. We just have to use roots or fractional exponents. I'm going to proceed with fractional exponents. Basically, we're going to raise both sides to the 1 over NT. Now, if you know your rules of exponents, these two will multiply, and I will have 1 plus R over N, as I hope. Now, what is 1 over NT in an exponent? It's the NT root, if you want to write it that way. It's also acceptable. So here I have Q over P to the 1 over NT equals 1 plus R over N. Now that's a much simpler right side than it started out as. So now we have to just subtract 1, because that's standing in the way between us and our R. So we do Q over P to the 1 over NT minus 1 equals R over N. Now all we have to do to solve for R is to perform the inverse operation of division, which is multiplication. So our answer is R equals N times the quantity Q over P to the 1 over NT, or the NTth root of QP, minus 1. And that is how you solve for R.